Welcome back, everyone. I'm happy to see my usual suspects here and on time. That's a good sign. Hopefully you got something done over the spring break and didn't just fuck it all off. Even if it was only a little bit. Who here did any homework this break?
My laptop was taken away from me.
I gotta tell you guys, when you don't do homework over the break, it really fucks you after the break. Like I've been a student, I know what it's like. When I didn't do homework over the break, I came back down a week off. Is like summer started. Effectively coming back to school after that, you're like, I don't want to do shit. And then so even if you only did half your homework before break, then that quickly becomes like, oh, I do it for 10 minutes long. I think I got it. And then like grades like start tanking right after Easter break and Thanksgiving break. Thankfully, Thanksgiving break is closer to the end than Easter or spring break, because like 5 weeks of not doing homework is going to kill you guys. All right, let's take a look at what we got here. We're doing chapter 12. We're starting. Chapter 12 is on roots and radicals. This is the last chapter for the next exam, which we will do next Wednesday. Today is Monday. We will finish up this chapter on Wednesday this week. On Monday, we'll do a review. And then on Wednesday, we'll do the test. The next chapter scheduled was chapter 13, but I'm going to go through, I'm going through it this weekend and figuring out what I can start like scrapping, because there's a lot of stuff coming up that I think they're trying to shove all the algebra topics down your throat when I don't know how many of you you're going to really need. Like this chapter, I really don't know how much stuff you're going to actually use in real life. There are areas where it comes in, but not very many that I know of. But I have it up, so we're going to do it. So we've already looked at like squares numbers, like 5 squared is 25. And that's like if I went that way. What if I wanted to go the other way? Break it up. I got to recognize it's 5 times 5, and that's 5 squared. So sometimes in mathematics, we want to know what this number is. We need this number here, but we don't even need the square. When we want just this number right here, the 5, this is the same thing as the square root of 25. This is called the square root of 25. Another way of showing it is having a 2 sit on this little ledge out front. And I want to show you kind of like where it comes from the exponents that we're doing. We just got doing exponents. If I have 5 squared equals 25, and I want to end up with just 5 to like the first power, I need to multiply. I can multiply or do this to the 1/2 power, and I can do this to the 1/2 power. 5 squared to the 1/2 is 5 to the 2 times 1/2, which is 5 to the first power. On the right side, I have a square root of 25. So these two must be the same. I'm going to put a little 2 over the edge right here. The way these fractional exponents work with radicals is whatever this number is right here. That's the number that's right there. And this number is the exponent right there, so like a 1 right there. Now that might be a little confusing. Let me write it another way. Let's see, let me do some other numbers so you can see kind of how it works out. Sometimes it's not just a square that we have. If I have 2 cubed, that goes to 8. There must be something I can do that gives me 2 by itself. The way this would work is, again, we're multiplying this by 1/3, so we multiply this by 1/3. 3 times 1/3 equals 1. And 8 to the 1/3, what I'm going to do is I have 3 on bottom. 1 on top. So I'm going to have 8 to the first power inside a radical sign that has a 3 right here. This one is called cube root. This is the cube root of 8. So what we have is really, if I want to put it in a general way, if I have the nth root of a, this is the same thing as a to the 1 over n power. These are examples, the 25 and 8 here are perfect powers. So 25 is can be written as 5 squared, and these are called perfect powers, perfect squares here. And 8 can be written as 2 cubed. That's a perfect cube. And collectively, we call anything like that falls in this category perfect power. Because when we want to go the other way, it gets, if you take the root of a perfect power, yes, thank you. With the right root. We don't have any more roots. Thankfully, your calculator will do a lot of this shit. But sometimes, as we'll see in the course of this chapter, it's easier to actually do a little bit of math, know how to do the math, and then plug it in the calculator because it's easy to fuck up the calculator work. There's just sometimes there's just too many buttons. Does anyone need that up longer? Okay. I'm going to look at that 2 cubed left, and that was 8. And I said the cube root of 8 is 2. One way you can get to there without a calculator is break down values inside of radicals into their factorization. Oh, this is called the radical sign. The value in here, whatever this is called the radicand. If you look at the book or that, say it there. I call it the inside. Radicand can be confusing. And sometimes, rather than saying that like a radical sign, we just get lazy and drop the word sign and call it radical. So I got that 8. And I know it can be written as 2 cubed. Because we have that over here. I can write this as the cube root of 2 cubed. All I've done is taken this line and said, okay, that goes to that. This root out here means I can take whatever's on the inside, just leave that the hell alone. And take the radical part and write it as a 1 over whatever this number is here. This is n, 1 over n, in this case 3, the 1 over n here. So value that's sitting on this like shelf. And when we had exponents like this, we can multiply them. So if we look at the first 10 numbers, oh, fuck it, let's include 0. This is actually the diagonal row on the times tables. On multiplication tables. If we wanted to look at x cubed, which maybe I should have made that ahead of time. Having seen the first 10 cubes is actually helpful when you're going the other direction. When you're trying to take the roots. Yeah, these are multiplying. They're not decimal points. I'm not using x to multiply because I have these x up here. No, 2 times 3 is 6. If you go slower, you do the first two. 2 times 2 is 4. So I've got 4 times 2, and then 4 times 2 is 8. It's all good. Let's see. $640 minus 128 is 512. So if you have like these numbers memorized. And I get like this starts getting a little harder to remember. Because we're starting to get into triple digits. But like the first 5 numbers, cubes are not too bad. And then all the squares aren't too bad because these are from your times table that you did as a kid. And they can help speed things up for you so you don't need a calculator. If I ask for the cube root of 64, I know 64 is 4 times 4 times 4. This is 4. This is because I can rewrite 64 as 4 cubed. And when you have this matches this, the number just comes out. The root comes out without the exponent. That might be a way to remember it. These can really help you if you're trying to approximate the square root and you don't want to get a calculator. Pause for a second. Make sure everyone's on the same page. And then we'll start going over calculator work. Like what you can expect to, what different buttons do the shit that you want to do. That green pen goes to the page. All right. So I'm just going to leave these over here on the side. At least the root part or the square root squares. If I wanted to estimate or estimate. Let's go with, I don't know, square root of 40. The way you can approximate this without pulling out a calculator, as long as you know these squares. Is go, okay, 40 is between 36 and 49. So square root of 40 is in between them. This is 6 and this is 7. $40 is 4 away from the 6 or 36, but it's 9 away from this one. So whatever I have is going to be, it's going to be above 6, but less than 7. It's going to be 6 point something. And since it's closer to 36, it should be less than 0.5. 0.5 is like the halfway mark. Since it's like quite a bit closer, I'm going to guess or estimate that this is like 6.3. Does that make sense? So before we do the calculators, don't do a calculator on this one. Try to estimate square root of 15. And then we'll find out if we're right. Let's try to see if you can come up with an idea of what it is without getting in a calculator. This is a skill that gets more accurate with practice. What two perfect squares is 15 between?
3 times 3.
Yeah, 3 times 3 and 4 times 4, 9 and
16.
9 and 16, exactly. Now we are 6 away from the 9 and only 1 away from the 16. So whatever this number is, the 3-point question mark is a lot closer to 4 than the 3. Here it's not really, you get more accurate with practice. I'm going to guess somewhere between 3.8 and 3.9. Probably closer to 3.9, but if I really need to know, we'll do it in a calculator. And we'll look at that in a second. This is actually handy when you're doing homework, you're on the test, you do something like that, and you're trying, you plug some shit in the calculator, and you're like, does it look right? You can like approximate it. And go, is my approximation anywhere near the actual answer that my calculator spit out? If I spit out the square root of 15 and it says 7.6, I'm way the fuck off. I'm nowhere, I did something wrong. I might have put in the square root of 51 or something like, I might have switched the numbers when I put it in. Don't tell them what you could have done. How does this look in a calculator? Let's check it out. Calculator work. Buttons come up on the calculator. There's a few different options. Some show that. Or the cube root button. So this is the square root button. And the cube root button. They also have something that some calculators do it like this. They write x to the 1 over y. And other calculators write the same thing where it looks like this, y root x. So, if you don't know how your calculator works, figuring out what the order sequence is can be a pain in the ass. Especially with these. This one, you only have like really two options. You can either try doing the square root button and then hitting 4 and then hitting equal. Does that give you 2? If so, that's the right order. Some calculators switch it around. Some calculators make you do the 4 first and then hit the square root and say equal. And does that give you 2? Each calculator is different. So I don't want to tell you how your calculator works because I don't know. Figure out which order sequence works here, and then you'll know whether or not you have to hit the square root button first or after you type in the number. Let's see what my calculator has. Let's see, function. Root. Oh, and if you are using an online calculator or something like this, it may not have one of these root things. Oh yeah, it does. I have the end root here. So for mine, I'm gonna try 4 and then hit the square root button. And I can see right away that it's telling me I did it in the wrong order. So instead, I'll hit the square root sign first and then hit the 4 and hit enter, and I get the 2. So in my calculator, I need to do this one first. Then try the same thing over here with like 8 and 3. Try doing 8, x to the 1 over y, and then hitting 3, and find out if you get 2. Or if your calculator has that, hit 2. So on me, and it might be the other way around, you might have to put the 3 in first. Which combination here gets you the 2? So mine is like this, but mine looks like that. I have the en route one, so mine is either that one or that one. And I don't know which one it's gonna be, so I'll just try them both. 8. That's giving me issues when I did the 8 first. If I do the radical sign first. I can see on mine, I don't know if you guys can see it. What? That's what? You mean notes?
Can read you the equation.
Yeah, I can come up here and edit. Kind of cool.
The Android.
It's Android, it's Desmos app. I get, and Apple's gotta have access to the Desmos app. What? It's just an Android phone, Desmos app. Oh, this one is called, the app's name is Desmos. It's an online graphing calculator, online graphing website. I think we looked at it when we did graphing in here a little bit. I think I've shown something on it.
With the A and B.
Yeah, but it has an app that does this. So it looks like for me, I need to hit. None of these options were correct for me. I need to hit the root button first. For me, I need to hit. I need to hit en root first on mine. Then it's got the flashy thingy above the exponent, so it wants me to enter the n first. And I hit 3. And then I gotta fucking move the cursor. Move cursor. And I'm off screen. And then I put the 8 in. And then the equal sign. Which is the return key for mine. But use numbers that you know. 2 cubed is 8, so the cube root of 8 is 2. You can, if you use numbers that you know what the answer should be, you can figure out how your calculator works. That was tricky. I didn't think to do this one first, right now. Calculators do have another option. Let's figure out 15 and our values up here. What do we have? We had square root of 40 and square root of 15. Let's take a look at what they are. Square root 40 says 6.324555532. So my 6.3 estimate was close. Square root of 15 is 3.87. And I had said between 3.8 and 3.9. And I was close there too. I did not know the square root of 15. I'm just going, how close is it to the 2 perfect squares? What are you up to? You're smiling for no reason. I don't trust that. It's hella sus.
How's your screen like?
Well, it was all right. She's trying to distract. You see what she's doing? She's trying to put my answer to delay a game on my ass.
How do you even? I'm just asking.
Everybody asked me how my spring break was before
But
class.
remember,
Delayed.
but Yeah,
It was not as productive as I wanted it to be, but I did get something done each day.
that's good. What game did you play? What have you been?
I actually didn't play a game. I was reading a lot of the free time or watching a TV show with my wife. I went and also saw Dungeons and Dragons, and I saw,
You did?
yeah, I saw the Dungeons and Dragons movie, and
Don't spoil
it's Dungeons and Dragons. There's monsters in it. There's
it.
heroes in it.
Yeah, but-
I couldn't spoil it if I wanted to. What else did I see? Not John Wick, Shazam. I saw Shazam. I like Shazam a lot. I think I like Shazam better than I like D&D. And I play D&D. I played D&D yesterday.
Do you like the Flash? Do you know they're coming out with the new Flash?
One of the previews on, I think Shazam was the new Flash.
Yeah, towards the end.
Yeah, I kind of like that on the preview. I'll give you one more minute on the fucking delay of game. I kind of like the preview on the Flash because he's doing his universe jumping because he's doing so fucking fast. Then he goes to, they show Michael Keaton as Batman. Michael Keaton was a Batman like 20, 30 years ago. He was like the first Batman on the movie screen. That wasn't like the TV show Batman. That was all super cheesy with the bam, pow, shit like that.
Yeah.
He was the first Batman, and they brought him back for the motherfuck. Give us a second.
Gosh darn it.
I like that they had him and someone else. I think they showed someone else that was there.
Yeah, I'm more into DC than Marvel.
I like Marvel more, just because they tend to make better movies. The DC is getting better. We'll see what happens under their new leadership. All
My
right,
favorite is Catwoman.
they had the Catwoman TV show.
Oh, yeah, I know, but it was.
It was a little too soap opera-y.
Yeah. I actually like the actual old movie.
Oh yeah, Halle Berry.
Yeah.
She's hot. That one's really good. That's some good villains in it.
Yeah.
I just like the story because it's a kid, a teenager, that fucking pops into a grown man superhero. It takes me back to being a teenager and wishing I was a superhero. You know, like having a more of an active imagination and just think about shit like that. It'd be so fucking awesome. It'd be awesome now, to be honest, but. All right, delay of game is over. We have another option on a calculator. Calculators also have a button called that. Some of them do. This button is the make whatever follows the exponent.
Wait a minute, you barely watched Shazam?
The new Shazam, Fear of the Gods.
I think we only watched like the first one,
No,
because that was a long.
That was- yeah.
Yeah.
I watched that when it came out. I rewatched that one like a month. Fucking, she's good, isn't she?
I was on,
She's fucking delay a game again, that quick.
I was on the, it was base, because he's in the Navy. We had just a whole theater to ourselves and watch that.
Nice.
It was pretty good. The chair selection. Really good experience.
The 4D can be pretty good if they do it right.
Yeah.
I heard in some theaters, the new Super Mario, they will have like, I know Galaxy doesn't have it because they don't have the mist thing. But some of the theaters have like mist come out, and he's a fucking plumber. Apparently, there's some scenes where there's water present. And it will actually, the fucking 4D sprays you with mist or something like that. All right, so
Fun.
we did this before in the previous section with exponents, where we had something like this is like 2 to the third power, which is 8. We can use this for radicals also. If I say 4 and I do the caret symbol. And then like parentheses. 1 divided by 2. And then end parentheses and then the equal sign. What this is writing out is 4 to the 1/2. And it should spit out a 2 as an answer. So if you have the caret operator, give it a try. Another way of doing this is 4 to the caret. I can do 1 divided by 2 without a calculator. 1 divided by 2 is 0.5. That should also give you a 2. All right, so more stuff that we can do. If I have x to the 1 over n. And I take that to the nth power. This is 1 over n times n. As the exponent, and this is x to the first power, which is just x. This is also in radical form, the same thing. These are identical. Also equals x. It also works the other way around. If I do the x to the n on the inside and the 1 over n on the outside, I'm still going to get x to the n times 1 over n. Did you like that? Did it make you hungry? It did. It's a little bit hungry, didn't it? Just equals x. This is the same thing as saying the nth root of x to the n equals x. So these two are the same. Now, if you reduce the delay of games, we will get out of here early, I promise, because it's my 19th anniversary and I don't want to be here any more than you do.
Congratulations.
Thank you. We went out to steak on went to Tahoe Joe's on Saturday and we're just having pizza tonight. No one wants to cook tonight. All right, simplifying roots. Take a look at simplifying roots. I guess I could put a little bit more on there and use it, do some examples of what we just had. If I take the square root of x squared, this is just x. And if I have the square root of x squared, I also get x. I think you'll find the following steps a little bit easier if you try to treat them as fractions. Yep, and another one just for you. Come sit back there. I'm gonna bring a tablet so that I can project to the screen and just sit right next to you on a day when I know I'm especially free.
You're talking to Nate?
No. No, I'm not talking to Nate. All right, so. This is the same thing as doing x squared times 1/2. And getting x to the 1. We can do this with higher things. I can have the square root of x to the 4th. And if you get practice in writing this as an exponent, this radical sign, we have 4 times 1/2, which is 2. This is x squared. Everyone ready? All right, if we do it with x to the 6th, the square root of x to the 6th. I'm going to show you an alternate route, but I'm going to do the exponent thing first, which is the shortest. Another way of doing this is writing this as x squared times x squared times x squared. And radicals can come apart. I can write this as the square root of x squared times the square root of x squared times the square root of x squared. Each one of those is x. So I get x cubed. This method, the idea here is break up the inside exponent into increments of the index. That's what when I have this is called the index. Now, a lot of times people write it really quickly and they'll do this. Something like that. You'll notice there's something distinctly different between that and what I have. I tend to add a little ledge right here, and I tend to bring down a value right there. I bring down a little tail right there. The reason why is when we start seeing the next section, if I have this is different than that. And if you're writing sloppy, you may not recognize it. Some people write it really sloppy and they'll write this as, and there's no ledge, and like the 3 maybe looks like it could be in front of it. So the little ledge out front kind of gives something the index to sit on. This thing actually tells me where the radical ends. It's not the same thing as 3 square root of xy. Because the radical is not covering the y. But if I bring a little ledge down and show where that ends, it's a little easier to not fuck up. When there is no number for the index, when the index is missing, it's a 2. They generally do for the square root, they don't show the 2. Because it's the lowest root we do. We don't do like a 1-3. Because that doesn't make any sense. So the lowest root we do is like a square root. But when we have a whole number, and so they start with 2, and they don't, just like we don't write a 1, the lowest number we would have for an exponent was 1. We don't write that, we don't do the index with 2. So what if let's give you guys another one. Let me give you guys one. Let's do the cube root of x to the 6th. What should I get here? I don't know what the hell I ate, but it was good. Tasty. You smell that? Tasty. Only because it grosses you out so much. It's good. You have a couple options. One of them is rewriting that 3 as a 1/3. And we have 6 times 1/3, which is 2. You could also break this up. Keep making this, take out pieces that match the index outside. I can write this as x cubed times x cubed. And when the index matches the exponent, that value comes out. What? You did in a second. All right, so these have all been, we've all had perfect powers on the inside. What if it's an imperfect root? So these are all perfect roots. There was no radical afterwards. What if I have imperfect roots? The square root of x to the 5th power. There's a couple ways of doing this. A lot of people like this, break it off like this thing. So I can keep writing, take the 5 and keep subtracting a 2, because I've got a missing index out here of 2. I can write this as x squared, and then this is 5 minus 2 gives me a 3 left. Then I've got another x squared. I've got 3 minus 2 gives me another x left, and I've got x to the 1st power. So all this down below, this is like exponent work right here that I would not do when I'm writing it down. But I'm trying to show what I'm doing. So I'm taking 5, I subtract the index. I get 2, I've got 3 left. I write it when I'm down, and then I do it again, I take the 3 that's left, I subtract the index, I've got a 1. And I can't subtract the index anymore because I start going into negative numbers. Each one of these that matches outside could come out. The part that doesn't match has to stay inside. This becomes x squared square root of x. The other way is the exponent route. I can also write this as x to the 5th times 1/2. Which is 5/2. If I write 5 halves as a mixed number, I've got 2 and 1/2. Which is really x squared times x to the 1/2. Which also gives me my x squared square root of x. Why don't I give you guys one to try?
My class isn't starting till 7.
So 2 ways of doing it. I can do this as x to the 8th times 1/3. That's 8/3. That's a shitty looking 8. Which is x to the 2 2/3. This is x squared, and then I've got x squared to the 1/3 like this. I end up with x squared times the cube root of x squared. It's a little harder that way. Because I hadn't really talked about having a number besides 1 on top when going the other way. Alternatively, you could have taken this number and subtracted the index. 8 minus 3 gives me 5. I can put an x cubed here. And then I could do 5 minus the index. That gives me a 2. That allows me to do another x cubed there. And I can't do 2 minus 3. That's kind of like I get a negative number. I don't want that. So this is x squared. Only the numbers that completely match the exponent index come out. And your other poor little guy has to stay inside. So this is x squared times the cube root of x squared. Yes, right? It's pretty important to know there is a difference between negative square root of 4 and square root of negative 4. Square root of negative numbers, we're going to do this on Wednesday. These are imaginary numbers, which is a terrible name. It makes it sound like they don't serve a purpose in real life. But electricity, with the mathematics behind electricity, like the current in a wall, depends on square roots of negative numbers. So, and other electronics and shit like that uses these imaginary numbers. So it serves a purpose. I don't know that imaginary is a great word for it. It's very misleading to someone that's new. This, we do the square root of 4 by itself, we get negative 2. And here we'll see this is square root of negative 1 times square root of 4. We'll see this gets us 2i again when we do it on Wednesday. We'll cover complex numbers on Wednesday. But just make sure you notice the negative on the inside is different than the negative on the outside. This stuff also works when we've got fractions in there. I could have x squared over y to the 4th power. Radicals, when they're divided, it splits up as doing the radical of the thing on top divided by the radical of the thing on bottom. The top part here, square root of x squared is x. The square root of y to the 4th is y squared. Let's see. I wrote this down, so it must be part of showing up in the homework. If they have something like this outside something. The plus minus isn't related to the radical. I can do the radical all by itself. This has got an invisible 2 on it. And I've got y to the 16/2 is 8.
So you're probably. That's the.
I'm taking, yeah, what I'm doing is I'm taking the index on the outside. And dividing it into the index on the inside. It's really easy to do it quickly if it divides evenly in. Like here, I did that here. 16 divided by 2 is 8. Bam. This is read as plus or minus. So plus or minus y to the 8th power is really saying y to the 8th power, the positive version, or negative y to the 8th power. Ready for some more? If we have something on the inside, we've got like square root of AB and I cube this. This is the same thing as the square root of A times the square root of B cubed. And then we distribute the exponent to both things. You have options. This here means square root of A times square root of A times square root of A. And I got times square root of B times square root of B times square root of B. Trying to show all different manners of doing this because everyone like picks up on something different and goes, that shouldn't make sense to me. I'm going to do it that way. And since there's a lot of ways to do it, I don't want to force you into doing any particular one. Whatever the index is on outside, this is an index of 2 for all of these. I'm going to group up that many. Index equals 2, so I'm going to grab 2 of them. This becomes an A. I can't do that with another A, so this is left as square root of A. I can pair this up. That's a 2. This becomes B. This is square root of B squared. And we talked about when we can do the exponents and it matches the index, it goes away. This just has to come down as square root of B. So I can put the A and the B together, they're out front. I have a square root of A times the square root of B. And I can put those together like that. We will do more of this stuff on Wednesday with 12.3, combining different radicals like this. You see that. This is always true. If I have two radicals multiplied together, I can make it one radical with the whole thing inside. And it goes both ways. I can break it apart or put it together, which is pretty handy. The other option we had, another option we have up here, I could write each of these as exponents. This is a to the 1/2 cubed, b to the 1/2 cubed. Which is a to the 3/2, b to the 3/2. And when you have it like this, you want to write those numbers as mixed numbers. A to the 1 1/2, b to the 1 1/2. Because it means a times a to the 1/2 times b to the 1/2. These go back under the radical. These, since they have whole number exponents, they just go in the front with the same exponents. I'm off screen. Let me give you guys one to try and see what you come up with. What? We're ordering pizza in, we're having it delivered, we're not just whenever we get home, when we're just gonna chillax. Watch some movies, maybe. You guys do? Anybody have any answer? No fear. All you can be is wrong or right. I should rephrase that. What's the worst thing you can be? That's wrong. That's the
I did 16y a times 1/4.
Like a times 1/4. Is that what you said?
No, 8.
8. Like an exponent of 1/4? Okay. Okay. Not quite what we want to do. We want to split it up and do the 1/4 on each of these together. Worth a try though. No fear. Well, you can do the 16 and the 1/4 here. Y and the 8th. Y to the 8th times 1/4 here. Now. You can either put this in a calculator. Or I can go 16 is 4 times 4. And each of the 4s is 2 times 2. So this is really 2 to the 4th to the 1/4. Here I could do the multiplying already. I got y squared. And the 4 and the 1/4 multiply together, make 1. And this gets us 2y squared. Just let there be light. And it was light. Ready for another one? We got a couple of these. Let's give cube root of 8x to the 5th y. Try working that out. I'm gonna rewrite 8 as 2 cubed. Write this as a 1/3. And then I'm gonna distribute that 1/3 to each of them. The cube and the 1/3 go away. This is x to the 5/3, which is 1 2/3. And this is y to the 1/3. Anything that has the exponent of 1, I can put up front. Anything else that doesn't has to go inside an index with the same thing. And I'm going to use the numbers on top as the exponent. As exponents inside. This will be x squared y to the first power. I think this is the in terms of trade school, probably the chapter that we've done so far that is the least helpful, which means the test is going to reflect that. We're not going to have very much on the test for chapter 12. Because I don't know how important it is that you master this. But give it a try. The other way of doing this is breaking this up. 8 is 2 cubed, we already said that. I can write this as x to the third power, x squared. That adds up to the x to the fifth. And I can't do anything with the y. A lot of people prefer this approach. Here, the index matches the exponent. Those get pulled outside without the exponent. And what we have left over has to stay inside the radical. That's a little bit easier than the fraction work, I think, for most people. Take a look at another. 50 a cubed b to the fifth power c squared. We'll take the approach I did last year. I think most people like that better. $50 is 2 times 25. And 25 is 5 times 5. So I can rewrite this 50 as 2 times 5 squared. I'm going to keep breaking up these exponents here into pieces of 2 because that's the index outside. I will write a cubed as a squared times a to the first power. B to the fifth power will be b squared times b to the first power. And if you write it out like this, when you're done, just double check 2 plus 2 plus 1 equals 5, the exponent I had here. 2 plus 1 here equals the 3. If it doesn't add up to what you did before, you did something wrong here. But then this is like, that doesn't work here. This you just need to multiply out. Make sure that equals the 50. When you've broken it down like this, now you just start pulling out anything that has an exponent of 2. And you drop the exponent. I've got 5a, I've got b and another b, and I got a c. Whatever's left over, I leave inside. 2ab. And then we don't write b like that. We would write the b as b squared. Ready for some more? Are we having fun yet? We're fucking having fun, aren't we? Don't act like you don't love this very honest. This is the best time of your life. You've never had more fun this semester. What if I've got something like this? This just follows the exponent rules of what we did before. More examples with fractional exponents. We distribute the 3 to each of them. This is, oops. 2 to the first power times 3, a to the 1/3 power times 3, b squared times 3. Two to the 1 times 3 is 3, so 2 to the 3rd power is 8. 1/3 times 1/3, or 1/3 times 3 is 1. And 2 times 6, or 2 times 3 is 6. Let's see, some more stuff, crazy stuff they might give you. They might give you a root like this. And then an exponent on the outside. I recommend doing the inside first here. Let's just leave that 4th power alone for now. And then rewrite 8 as 2 cubed. If you need to do a little factorization tree to get that, you can. You likely will until you've got that cubes memorized and stuff like that. I'm going to take the x to the 6 and break it up into powers of 3. I'm going to take the y to the 9th and break it up into powers of 3. All right, so all of these, first off, I'm going to verify. I got 3 plus 3 is 6. Good. I got 3 plus 3 plus 3 is 9. Also good, that matches those two exponents up above. This means, and I still have that fourth power outside. I can pull out a 2, I can pull out an X, another X, a Y, a Y, and a Y. This is 2x squared, y to the third power, to the fourth power. Now we distribute that 4 to each exponent. I've got 2 to the 1 times 4, x to the 2 times 4, y to the 3 times 4. And the fourth power is 16. And then 2 times 4 is 8, and 3 times 4 is 12. Two to the fourth power. All right, we can get into some shady shit. I'm gonna write it the way you would see it as a radical first. This is really x to the 1/2 divided by x to the 1/3. Now, those of you that worked on the homework over the week might remember when we have division like this, we subtract the exponents. Subtract the bottom one from the top. And get a common denominator. What the hell? Ariana's is doing her own shit and I make eye contact with her for a second. And her face goes like this. I'm fucking crackhead over here. Fucking with me.
Cause I knew you were hearing their conversation.
Are you listening to them? I'm glad you're listening to them and not me. That's effective learning right there.
It was only like a quick minute, and then like 2 years, and I was like,
Almost done. Something similar. 10y to the 4th over 5y to the 1/3. Should do the 10 over 5 separately. And this we can subtract exponents.
No, it could be. Do you think so?
I'm not a doctor, I'm not gonna prescribe you with that. All right, so the 10 divided by 5 is what? If I rewrite this 4 as a 3 plus 1/3, I think it's a little bit easier than getting a common denominator. But still got the minus 1/3 there. So I'm taking that and rewriting it as that. I think it's a little easier to see. I end up with 3 and then 2/3 without getting a common denominator. What's wrong, Bertha?
Why is it 4 equals 3 plus
What is 3 over 3?
1?
1. So 3 plus 3 over 3 is 3 plus 1. Just 4. The other option you have,
So you,
and if you don't like
so
that,
you turn the 4 into fraction.
I broke off a 1 from the fraction, from the 4 to make a fraction. The other option is getting a common denominator. I need to get a denominator of 3, which means I need to multiply this by 3 over 3. If I do, I get 12 over 3 minus 1 over 3 is 11 over 3. Which is 3 2/3. Whichever approach works for, or you like the best. And if I were to write this as a radical. Again.
So this is how much.
Okay, where is this helpful? Where's doing some of this shit helpful? Let's say I have 3 to the 1/2. Times 3 to the 3/2. If I want to put this in a calculator, this is 3. I do the caret thing. I do the parentheses. 1 divided by 2. Parentheses. Then divided by 3, not divided by, times. Times 3, I gotta do another caret. 3, oh, that requires a box 2. 3 divided by 2. And caret. Yes,
And
not and caret, and parentheses. Thank you. This is easy to fuck up. Putting in a calculator. Instead. let's add the exponents. At this point, I don't even need a calculator. I think it's enough abuse for today. That's it for today, folks. You don't have to stay here, but you don't have to go home, but you can't stay here. Is that how they say it?